Today we're going to look at transforming the graphs of sine and cosine. So let's start with sine. And first let's just remember what the basic graph of sine looks like. So we're going to graph f of x is equal to sine of x. Now yesterday we were letting our input variable be theta, but now we're just going to call it x so that we have a function of x. But x still represents an angle, and remember it's going to be measured in radians. And so let's graph this. And remember the sine function, basically as we travel around the unit circle, the sine function is just giving us as its output what the y-coordinate is of that point. And so when we start at 0, at an angle of 0, what's the y-coordinate on the unit circle? Oh, it's 0. So there's our first point at 0, 0. Now when we go all the way around the circle, we're going to end up back at an angle of 2 pi. So that gives us one complete cycle of the sine wave. And what we're going to do is we're going to just plot some points here, in particular 5 points. They're going to act as guidelines for drawing the sine wave. And these points are going to occur, well, we know we get a y-coordinate of 0 at an angle of 0. We also get a y-coordinate of 0 at the angle 2 pi, and also right in the middle at pi. Okay. Now halfway between 0 and pi, that's pi over 2, which that would be like the top of our unit circle. And remember the y value there is 1. So we get this point, pi over 2 comma 1. That's the maximum of our function. And then if we come to the bottom of the circle, and that occurs halfway between pi and 2 pi, and to find the angle in the middle, we just take their average, which is 3 pi over 2. And we know at the bottom of the circle we have a y-coordinate of -1. So that would be our function value. So we have this point, 3 pi over 2, comma -1. And when we connect the points, we get this sort of picture. We get our sine wave. And of course, this function just repeats itself to the right forever and also to the left forever. This is just one cycle of the sine function. And remember, one complete cycle, the length of that we call the period. So in this case, we would say our period is 2 pi. All right, now let's take a look at actually transforming this graph. So for our first example of a transformation, let's graph f of x is equal to 3 times sine of x. Okay, so we're just multiplying our function by a number. I remember when we multiply a function by a number, what does that do? Well, that's going to be either a vertical stretch or a vertical shrink. In this case, since the number we're multiplying by, 3, is larger than 1, we know we're going to stretch our graph. All right. So we're still going to get the same sort of shape. The only difference is instead of going up to a maximum value of 1, we're going to go all the way up to a maximum value of 3. So I'm going to label 3 on my f of x axis. Similarly, our function value, instead of going down to -1, we're going to go as far down as -3. Right? And we're still going to plot those 5 points like we did before. And notice our period is still the same. We're still going to go from 0 to 2 pi. If I finish labeling my x-axis, we have pi in the middle. Halfway between pi and 0 is pi over 2. Halfway between pi and 2 pi is their average, 3 pi over 2. Right? And now we're going to follow the same pattern. Remember with the sine wave, we went 0 up to 1, back to 0, down to -1, back to 0. Well, now we're going to do the same thing, except our high points are going to occur up here at +3. Right? So we have 0, then we go up to +3. This is the point pi over 2 comma 3. Back down to 0, down to -3. This is the point 3 pi over 2 comma -3. And finally back up to 0. And this gives us one complete cycle of our function. Okay. So what we changed here was the height of our sine wave. We call this the amplitude. So the amplitude is just the height of our sine wave. So here we would say that our amplitude is equal to 3. Right? And in general, by definition, the amplitude is the height of the sine wave. All right, let's look at another example. So example 2, let's now graph f of x is equal to negative 1/2 times sine of x. All right, so now we're multiplying by negative 1/2. So first of all, let's think about our amplitude here. We're going to be, well, instead of vertically stretching our graph, we're actually shrinking it, right? Because 1/2 is smaller than 1. Okay, but what does that negative do? Oh, that just flips our graph. We're going to have a reflection over the x-axis. But by definition, the amplitude, it's the height of our sine wave, and so it has to be positive. So to find our amplitude here, we're just going to take the absolute value of negative 1/2, which gives us, of course, positive 1/2. So now when we go to graph our function, okay, when I go to label my y-axis, my f of x axis, we're going to be going, instead of up to 1 and down to negative 1, we're going to be going up to 1/2 and down to negative 1/2. All right. And to label our x-axis, that's going to be the same. Our period is still the same. From 0 to 2 pi will give us one complete cycle. In the middle, we got pi. We got pi over 2. And over here, we have 3 pi over 2. Okay. And now let's start plotting our points. And we're still going to start at 0, 0. You can see if you were to plug in x equals 0, you would get sine of 0, 0, multiplied by negative 1/2. You still get this point 0, 0. Okay. And now for our next point, notice that negative 1/2. That means that we're reflecting over the x-axis. So instead of traveling up to positive 1/2, I'm actually going to start by traveling down to negative 1/2. And this is going to be my next point, pi over 2 comma negative 1/2. Right. And then in the middle, we come back to the x-axis. As we come over to 3 pi over 2, now we're going to travel above the x-axis. So 3 pi over 2 comma 1/2, that's our maximum. And then finally, we'll end up back on the x-axis at the end of our cycle. And there we go. All right, let's take a look at one more example. Example 3. So we are going to now graph f of x is equal to sine of 2x. All right, so now notice what we're doing here. We are multiplying by a number inside of our function. And what this does, instead of vertically stretching or shrinking our graph, this is actually going to give us a horizontal stretch. Well, what does a horizontal stretch do to a sine wave? It changes the period. So what we're going to have here is a change in the period. All right, so I'm going to go ahead and start to graph this. So we have our x-axis, our f of x-axis. Okay, and now let's think about what the period is going to be. If we were to consider just our regular sine wave, f of x is equal to sine of x, well, we know that the period in this case is equal to 2 pi, which means that one full cycle, x is going to complete one full cycle on the interval between 0 and 2 pi. Right? As x travels between 0 and 2 pi, we go around the unit circle, one full trip. Right? Well, now, if we are looking at, so this is our basic function, but now for this guy, our function is f of x is equal to sine of 2x, which, what does that mean? One full cycle, what we have is that 2x is going to travel between 0 and 2 pi, and that'll give us one full cycle. Okay, but let's see, what is x doing? So for this inequality, it's just like solving an equation. If we want to get x by itself, we just, well, divide both sides by 2. And in this case, we're just going to divide everything by 2. And if we do that, we'll end up with 0 is less than x, which is less than 2 pi over 2 is pi. All right, so there we go. Our period is now pi. Now, in general, if we want to find our period, if our function looks like this, f of x is equal to sine of some number, let's call it b times x, well, then the period is going to be given to us by the formula 2 pi, and I just divide by this number b. Just like we did up here, we divided by that 2, and we got a period of pi. Well, now we're going to do 2 pi divided by b, and this is kind of in general. So this is important. This is to find the period in general. All right. Now let's go back to our example. We are going to graph this function. And like we said, our period here is equal to pi. So my full cycle is going to start at 0, and this time we're going to end at pi. And we're still going to get the same sort of shape. We're going to go, start at 0, go up to 1, back down to 0, down to -1, back to 0. But what we have to do is we have to label this x-axis properly. And so let's see. Halfway between 0 and pi is pi over 2. Now what's halfway between 0 and pi over 2? Well, you could refer to your unit circle, or if you just did a simple calculation, basically we're taking pi over 2 and dividing it by 2, which is the same as taking pi over 2 and multiplying it by 1/2, which gives us pi over 4. So this guy here is pi over 4. And well, what's halfway between pi over 2 and pi? Well, that's going to be 3 pi over 4. Okay. And let's go ahead and draw our points here. So let's see, the sine wave. It starts at 0. It goes up to 1. Notice there's no amplitude change. If I don't see a number in front of sine, it's just kind of understood to be a 1. So we go up 1, back down to 0, down to -1, and back to 0 again. All right. Now it's always good practice to just kind of label your points here. Like this guy here would be pi over 4, 1. This guy here would be 3 pi over 4, -1. But as long as you label your x-axis and your y-axis clearly, that should be enough as well.